All right, as we're doing this lesson, you're going to want to look at the yellow box on page 267. I learned my lesson with the 5th grade. With the 5th grade, I told them, just read this. It tells you everything you need to know, and it does, but they didn't get it. So, we're going to do a quick lesson about it. All right, well, first off, let's look just at point, line segment, line, and ray. A point is just what it sounds like. It's just where it's at. It doesn't go anywhere. If you think about on the grid on yesterday's lesson, 266, it had that grid at the bottom, and there were animals where the chicken was standing. That was a point. It didn't move. A line segment is a line that has a definite beginning and end. When we measure things, we use line segments. It's where it starts and where it ends. Whereas a line, this arrow shows that it keeps going, that it's indefinite. You might be measuring a point on it. For example, if I were to go outside and measure the flower garden, well, that's really kind of a bad example because that does have a point. But if I were just to measure the land where it's going to be, there you go. Yes, that section has a measurement, but the land itself keeps going. Even if you think about, oh, but it hits the ocean. Yeah, but it still keeps going under the ocean. It wraps around. We're not going to find a start and an end when we're measuring like that. Even if we could, I don't know about y'all, but I don't have enough ruler to do that. The last one is ray. And a ray has a definitive point, but it keeps going. So it can either have a spot where it definitively starts, or it can have a spot where it definitively ends. And so, for example, let's go back to the flower bed. My flower bed may not have a definitive start, blah, blah, blah. May have, like one way it just keeps going. But then on the other side, it goes straight up to my house and it stops. So it has a definitive stopping point, but it just keeps going out into the yard. Except it doesn't, because I'm lazy and I'm not planting that many flowers that I have to take care of. But if I weren't lazy, it could. All right, so those are those examples. Now let's look at angles. Anytime we've talked about shapes, I'll go, how many sides does it have? How many vertices does it have? And remember, if it has vertices, it has the same number of angles. The vertices are the points on the outside. The angles are this here. And they're actually instruments that you can use to measure the degrees of those angles. So the inside is called an angle. Angles are made, and you can see this on number 1. Angles are two rays that share a common end point. So that ray's going this way, that ray's going this way. They end right here. This is their angle. This ray is going here. This ray is going here. They meet right here. This is their angle. Okay? Congruent angles are the same. Anytime you see that word congruent is just the big mathematical term for same. So, going back. Because this triangle is an equilateral triangle, all the sides are the same and are equal, then these angles are all going to be the same and equal. Intersecting lines just mean that if the lines have any angle to them, they're going to eventually run into each other. It could happen really quickly, like here. It could be straight up and down like that. One could be straight. One could be cattywampus. But eventually, two lines that are at different angles will meet and cross each other. This is how you can be, you can be going straight and someone else can be going straight, but y'all could still wind up running into each other because you're not running parallel to each other. And that's our next word. No, it's the next to the last, but we're going to go ahead and skip to it. Parallel lines will never meet because they run side by side. They can either go long ways, up and down, or cattywampus. Those would actually meet because they're not the same. Miss Charlene doesn't draw straight lines very well, boys and girls. Pretend with me. If those were straight lines, I will do this. Hello, Anna Kate. Even though she knows I'm videoing, she wants to tell y'all hello. Okay, these lines are parallel, so they're not going to intersect each other. Now go back up one on your list and you see perpendicular lines. Remember I talked about how when lines intersect, they cross each other somewhere on the line? Well, if the way they cross each other forms a right angle, I skipped right angles, a right angle, then you've got perpendicular lines. All a right angle means is that it's a straight line up and a straight line across. And you see them all over the place. This board has a right angle because when it intersected. You see it all over the place in homes because you want right angles. Those make nice, straight, strong lines. All right. So that's everything on that yellow page. I do want to point out something. With intersecting lines, they will never intersect more than once if they're a true line. So, let's say that my line goes all the way down this board. Well, if I draw other lines, they can only cross it once if they stay straight. So, if the line goes pretty much straight up, it can still only cross it once. If it runs like this, but not quite parallel, eventually it crosses, but it's only going to cross once. Because otherwise, to make it cross more than once, you would have to draw a line, and then your line would have to go down and then like loop around and come back up and do all kinds of, doodly-doodly-doos. And that's not what we're talking about. We're talking about straight lines. Straight lines only intersect each other one time. All right, so let's do a real quick review. Point. Two dots. Line segment. Line. Ray. When two angles are identical, they are called, no, not upside down mountains. Not upside down A's. Congruent, yay! How many times can my lines intersect each other? Just one time. What are lines called that will never intersect each other? Parallel lines. Very good. And if a line intersects perfectly to make a right angle, it's called a perpendicular line. Good work.